Welcome back to our live training session here with our Honda EP3. Now, this training module, we're going to upload the file that we've built in the last two training tutorials, get online with the Motec, and then go through some basic sensors checks to make sure that we have our inputs configured correctly, everything looks in order. We're going to do some output tests, make sure that the outputs are actually functioning. Then we're going to go and do the drive-by-wire throttle calibration process, taking a look at doing some PID tuning. We'll fire up the engine, we'll sort out our idle control and our fuel and spark timing in idle conditions. So there's a lot to unpack here, and this is really going to be the first step in getting your engine fired up and running with your Motec. So let's go through and try to break this down as detailed as possible in this training module. First thing we need to do here, we can jump onto the Motec software, my laptop screen. We're going to go ahead and upload this to the Motec M1. So I have my ignition key powered on, and I have my Ethernet plugged into my laptop. I'm ready now to upload the file and then get online. What we can find here is it's showing up at the top, not connected. So we don't have a connection established yet. We can go in here and go onto the quick launch and jump in here and just click the ECU. That'll allow us to communicate and get online with it right away. What I'm actually going to do here, while I have the file open that we've created in that last two training modules, we're going to go ahead and send this to the ECU. So we're going to go to File and then Send. This is going to go ahead and upload it to the Motec. We can see it is connected here, and we're going to find that it looks like it sent it right away. So depending on if you've connected before with the Motec and depending on some other factors, it may prompt you where it's going to be showing an upload status. I've actually uploaded this just to do some quick tests before I started to film. That's why I didn't prompt up on the screen showing that it was sending for a few seconds. So the file has been uploaded to the Motec. We are online with the Motec. We can see here our time plot starting to stream. We are connected. We are live. Now let's start going through our sensor check and some output tests. Then we'll move into the drive-by-wire calibration process, getting our pedal and our throttle body sensors calibrated, and then just setting up the PIDs so that it's going to work for our throttle control. So as we're giving it a desired target throttle from our pedal movement, it's going to meet that or get reasonably close to it. So let's jump in here and first talk about our fuel tuning window right here. Under our channels, we can see that we're first going to be looking at our inlet manifold pressure. This is our map pressure reading. Now it's showing 100.4 kPa. This is accurate because I am at approximately sea level where my shop is located, and about 300 feet above sea level. So this is relatively accurate in terms of the value. This means that my map sensor calibration, the voltage translation table, was correct. We're using an OEM Honda map sensor, so depending on what your map sensor is going to be, it should still calibrate relatively close if you're at sea level. Now, if you're at elevation, it's going to change. It's actually going to read a lower value depending on how high up in elevation you're going to be. But sea level, this is accurate. So we can look at that and definitely understand that that is going to be correct. Ambient pressure is going to be our baro pressure. It is showing the same as our map pressure reading, and that is the way we have set up the baro pressure sensor. It's going to sample the map sensor key on engine off to get a baro pressure for its internal calculations. So this looks correct. Throttle position here is showing 4.6, 4.7%. We haven't done anything with that, so that's not going to be valid. If you're on a cable throttle body, you do need to calibrate your throttle position sensor so it reads 0 when you're off the throttle. Drive-by-wire is going to be different. It's going to actually show the actual throttle blade in its travel between 0 to 100%. So right now it's parked, looks like maybe at a neutral position of about 4.6, 4.7, but we haven't done any calibration with that yet, so we can't rely on it. Coolant temperature. This should reflect approximately to your ambient temperature when your key on engine off and the engine is cold. You can see right here 17 Celsius. This is about the ambient temperature here in my shop, so that looks accurate. Now what we want to do here is take a look at our intake air temperature, intake air temp sensor reading. It's showing about the same, showing 17.6 Celsius. They're relatively close in the readings, and that is going to be normal. Usually find the coolant temp sensor is a touch cooler in its reading compared to the inlet air temp, simply because it's submersed in fluid, but sometimes they'll match identically. So this looks good here. This confirms that our coolant temp and our intake air temp calibration, at least on the colder scale, is accurate. These should reflect ambient temperature, key on, engine off, cold engine. All right, let's move on here. We see our battery voltage is about 12.2. Looks good for battery volt. The battery is actually brand new in the car. I haven't even fired off the engine with it yet. I've swapped over the throttle body and converted this drive-by-wire, which required me to do a new intake and then relocate the battery and actually make a smaller battery to be able to fit everything here in this tight engine bay. So that looks good. The battery looks like it's healthy. Taking a look here, let's go down a little bit further. We are going to find fuel pressure. It's reading here about 250 kPa. So we know our fuel pressure sensor is actually registering and reading. If we test our fuel pump output, which we're going to do here in this tutorial, just to make sure that it's functioning, we should see that the fuel pressure, as we're priming the pump and testing it, we should see what the actual true base pressure is going to be. It's important that we take that true base pressure when we're testing and go into the fuel pressure estimate and populate that for the value in case the fuel pressure sensor dies or becomes disconnected or has some kind of fault or issue. It'll refer back to a correct base pressure reference in the fuel pressure estimate value. Again, we're going to look at that here in a little bit. Going down here a little bit further, fuel composition sensor showing 12% ethanol content in my petrol fuel. So typical gas stations in the United States, most gas stations here, at least on the East Coast, have 10% ethanol in the fuel, and we're seeing 12% right here. Now, I was filming this vehicle in previous training modules with other systems when I was doing a flex fuel based tuning. This does have that flex sensor. I did have a little bit of ethanol blend in here probably still, so that's why we're seeing it's not quite 9-10% as what we would find or should find from the pump up the street here, the gas pump. So that looks fine. 12% is completely sufficient here. Taking a look at the other parameters, nothing else in here is really valid for right now. So we know the sensors, the main sensors that we're worried about here, the major sensors. We have manifold pressure, we have coolant temperature, we have intake air temp, we have fuel pressure, we have ethanol content sensor. They're all reading correctly. Now, the other thing we don't have sorted out yet is going to be our accel pedal sensors and our drive-by-wire throttle plate sensors. So there's going to be dual sensors in the pedal assembly and dual sensors in the throttle body assembly. We have to actually calibrate that in the drive-by-wire setup. Let's first, before we jump into that, let's go and actually take a look at jumping in and testing our outputs so we can just verify things are functioning correctly. Something like our cooling fan or something like our fuel pump is going to activate. We don't want any surprises if we're trying to fire up the engine or if the engine's coming up to operating temperature and it starts to overheat because the fan's not working. So let's verify that some of this basic functionality is going to work here. I always like to do this even though I know everything's wired correctly and it should work. We don't want to guess. So let's just make sure things are in order here. I'm going to go for my tuning page here and under setup, and then go here under all calibrate, and we're going to jump down here under coolant and we can test our fan here. So we're going to find there's a test function. If I go here to enable, I can hear the fan kick on. I don't know if you're able to hear that in the audio. So the fan is working, so I have actual confirmation that it is functional. So we've programmed the fan to come on, I believe it's based on the coolant temperature here, 90 Celsius, and a 4 degrees hysteresis for it to turn off. This is good for the fan onset temperature to actually kick on. We could even lower that down to something like maybe 85 if we wanted to kick it on maybe a little bit sooner to keep things cool. So let's go ahead and minimize this. Now,
thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.